Hi everyone, in this video we are going to discuss the four pillars of OOPS, the four pillars of object oriented programming. Alright, first of all, let's list them out with what are the four pillars of OOPS. First of all, there is encapsulation, then there is inheritance, then there is abstraction, and there is polymorphism. Right, so these are basically the four pillars of OOPS. We are going to understand each and every pillar in detail. First of all, let's understand encapsulation. Okay, so encapsulation is nothing but data hiding. Encapsulation is nothing but data hiding. Imagine a capsule in which you have data member and member functions. Right, imagine a capsule which has data members and member functions. Right, now we have wrapped these data members and data functions in a capsule. Right, now over here in object oriented programming, the class that we have is working as a wrapper. The class that we have is working as a wrapper for our data member and for our member functions. Right, now for example, we have animals over here. We have made animal class over here and we have object of animals over here. We have wrapped all the data members. All the data members means all the states and all the properties of this particular animal, and all the member functions, which means all the functions get weight, set weight, eat, sleep, etc. We have wrapped all these functions in this particular animal class. Right, now there is something known as perfect encapsulation. What is it? Perfect encapsulation means each and every data member inside the class is marked as private. Each and every data member inside the class is marked as private. Right, now how are we going to access all the members which are marked as private? We are obviously going to use getters and setters. Right, we are obviously going to use getters and setters. Alright, so what is perfect encapsulation? Perfect encapsulation means every data member is marked as private. Why do we need encapsulation? Why like our question should be, why do we need encapsulation? Why do we have to mark each and every data member as private? Because of security, because of privacy. Because what if we have to make read-only class? Then we would need encapsulation. Right, so we have understood what encapsulation means. It basically means data hiding. We have wrapped all the members and data members and member functions in a capsule, which means over here capsule is a class. There is something known as perfect encapsulation, in which each and every data member is marked as private. Why do we need it? We need it for security, we need it for privacy, and we need it if we have to make read-only class. Let's move on to the next one. Right, let's move on to the next one, which is inheritance. Alright, so in inheritance, what will happen is, for example, there is a father. Right, there is a father, and father has brown hair. Now this father has a son who also has brown hair. Right, now this father has a son who also has brown hair. Now we can say that son has inherited some properties from his father. Son has inherited some properties from his father, right? Right. Now in inheritance, what are we going to have? We are going to have a parent class. We are going to have a parent class, which can also be called superclass, which can also be called base class. In inheritance, we are going to have a parent class, which can also be known as superclass, which can also be known as base class. Under this parent class, we are going to have subclass, which can be called as child class, which can also be called derived class, right? Now every property that is there in the parent class can be inherited in this child class. Every property from the parent class can be inherited in the child class, right? Right. Let's look at one example. First of all, let's look at some syntax, how this inheritance works. First of all, we'll have a class child. We'll have a class child. Right over here, we are going to have something which I'll tell you, and we're going to have parent. We are going to have parent. So we have a class child, we have something, and we have parent. Now, what is this something? What is the something? This something is mode of inheritance. Mode of inheritance. Now we can have three modes of inheritance, right? We can have public, we can have private, and we can have protected. We can have three modes of inheritance. It can be public, private, and protected. This is syntax of inheritance. We have a class which is child, mode of inheritance over here, and the parent class, right? Right. All right. Now for example, we have a class animal. We have defined a class animal which has age, which has name, and which has weight, right? Now let's just go ahead and remove these constructors over here, and we can remove getters and setters also. It has some behavior: eat, sleep. We can remove these print functions and destructor. We have some behaviors: eat, sleep, and we have some data members and member functions. Now we have to create an animal. Let's create an animal named doggo, right? Let's create an animal named doggo. Or what we can do is we can create a child class. What we can do is we can create a child class. For example, we have to create two animals. Both of them are dogs. Dog 1, dog 2. And these animals have same properties as the class animal. Some properties are different, but most of the properties are same. Why don't we create a child class named dog, which will inherit each and every property of class animal? And also it is not necessary to include each and every property. Okay, let's see. Now what if we create a class dog? For now, let's keep the mode of inheritance as public, which is inherited from class animal, right? And we can create an object of this dog class. We can create object of this dog class d1 d1, and we can call the function from this animal class. Let's go ahead and call d1.eat. Let's go ahead and run this. Alright, so semicolon is expected. Let's go ahead and run it again. As we can see, eating is getting printed. Even though we have not defined anything in this particular class, in this dog class, it has inherited each and everything from animal class, right? It has inherited each and every property from this animal class. Now we have an important chart. we have important chart related to the modes of inheritance, right? Let's insert a table over here. All right, 4, and let's keep it as 4. All right, all right. Now this is our base class, right? This can be access modifier of base class. Over here we can write access modifiers of base class. Over here we'll have mode of inheritance, right? Over here we'll have mode of inheritance. We have 3 types of modes: public, protected, and private. All right, over here also access modifiers of base class can be public, it can be protected, it can be private, right? Now let's see what happens over here. Now if the access modifier of base class is public and the mode of inheritance is public, right? If it is public and the mode of inheritance is public, then all the properties gets public. Then the properties in the child class gets public, right? If access modifiers is public but the mode of inheritance is protected, then the properties are protected, right? If the access modifier is public and the mode of inheritance is private, then everything gets private. If the access modifier is protected but the mode of inheritance is public, still the properties remain protected. If it is protected and protected, then obviously it will remain protected. If this is protected, this is private, then everything would be private. We have to remember that in case of private, even though we have inherited, even though we have access modifiers as public and protected, if we are inheriting it in private mode, everything will remain private only, right? Now what if we have access modifiers in the base class as private? Like for example, in this example, if we have these age, name and weight as private, but if we have another inherited mode, if you have this as private but we are trying to access it as public, we cannot access it. These things are not applicable. If the access modifiers in the base class of any particular entity is private, but we are going to we are trying to inherit those properties in the child class by using any other mode of inheritance, we cannot access it. These things are not applicable. All right, so now let's try each and every mode of inheritance. Now all the values are public, we are trying to access it through public. As we saw that eating would get printed, right? Eating would get printed. But let's see, everything is public but the mode of inheritance is protected. Everything is public but the mode of inheritance is protected. Now what will we do over here? What we can do over here is we can create a member function which will print this class. We can create a member function. Let's see, the member function would obviously be public because we want to access it outside the class. We can print the age. What this is going to do is this will go ahead, this will point to the age of the parent class, which is public, but we have accessed it in protected mode, and inside the function we can access it. So inside the function only will print it, right? Eat is inaccessible. All right, so eat is inaccessible. Why? Because everything is public and we are inheriting it through protected, so we cannot access it. But if we remove this, we remove this, nothing gets printed, right? Nothing gets printed. Why? because we have accessed it inside the class. We have accessed it, we are not getting any errors. We have accessed the age of animal inside the class, but outside we cannot access this because it is protected, right? Now what if it was private? Now what if this was private? What will happen then? Over then also we'll have this, we can do day1.print, we can call this function, we can run it, we'll get the age, right? What if this was protected? Let's try this again. It is printing the value because we are calling the setter, right? We are calling the setter. All right. Now for protected, as we saw in that table, for protected, or the public was protected, the protected was protected, and private was still private, right? All right, let's move on and understand the type of inheritances. Let's understand the type of inheritance. We can have many types of inheritance, many types of inheritance: single, multi-level, multiple, hierarchical, hybrid. We have a lot of types of inheritances. Let's understand each and every one. Alright, first of all, let's see single inheritance. In single inheritance, we have one parent class, we have one child class, and child gets inherited from parent, right? The properties of child gets inherited from properties of parent. Pretty simple stuff, right? Pretty simple stuff. Let's take an example. Let's write our main function over here so that we don't lose it. All right, let's take an example. Car. We have a class named car. Now let's mark the data members as public. We have a name of the car, right? We have weight of the car, right? And we have age of the car. Age means how old, like how many years ago the car was built, right? Now let's have some member functions. Speed up. Let's have a speed. Let's have a member function speed, and we'll just print speeding. Let's have a member function brake. Okay, braking, because brake is already defined, so it will not let us define it. Put brakes, right? Put brakes. Okay, now we have created a class named car. Now we have a car, Tesla, and Tesla is a car, right? We have a car named Tesla and Tesla is a car. So this will be single level inheritance. Because each and every property of Tesla will be inherited from car. We have one child class. We have one child class Tesla, we have one parent class car, and every property in Tesla will be inherited from car, right? Let's see multi-level inheritance. In multi-level inheritance, it is same as like hierarchy in the family. We have a parent, we have a child, then we have a grandchild, right? So in multi-level inheritance, we'll have parent, we'll have child, we'll have grandchild, right? Now, what this means in this relating to this example of car, car, we have Tesla, we have types in Tesla, right? We have car, we have Tesla, we have types in Tesla. So the types in Tesla would be grandchild, right? Types in Tesla would be grandchild. A better example over here would be to take an example of a fruit, right? Let's create a class named fruit, which would have name of fruit. Let's just have name of a fruit. Now let's create some child classes. Let's create a child mango, right? Mango will have every property of fruit. Mango will have every property of fruit. For example, this mango has a property like a data member weight. We need to know the weight of the mango. So this particular class, which is a child class, has a data member weight. Now let's make a class Alfonso, right, which is inherited from this mango class. We have to notice over here, this is the grandchild, this is the child, this is the parent, right? We have inherited every properties from this mango into this Alfonso. We have another member function over here, data member over here, for example sugar level. We need to know the sugar level of Alfonso, right? So this is multi-level inheritance, right? Multi-level inheritance. For example, we create an object of this class Alfonso. We create an object of this class Alfonso A. Now we have to access name of this. We have to access name of this. We have to access weight of this, right? We have to access name weight of this, and we have to access sugar level. We have to access its sugar level. Even though we have not defined the weight and name in this particular class, we'll be able to access the weight and name because this is child class. This is basically a grandchild class, but yeah. Alright, 0 is getting printed because we have not set the values. It is just returning the garbage values. If we set the values, okay, a dot name got repeated, it should be weight, right? A dot weight can be 50 kgs, lbs or whatever. Sugar level can be 15. Now let's go ahead and print this. Sugar level was not declared. Sugar level was not declared. Okay, a dot sugar level. We have not named the object, right? Yeah. So as we can see, we are able to access each and every property of parent class and child class from the grandchild class, from creating an object of the grandchild class, right? All right. Now let's see multiple inheritance. In multiple inheritance, for example, we have A and we have B and we have a C. So every property of A, not every property, but properties of A and properties of B are in the properties of C. There is a class A, there is a class B, and C is a mixture of both these classes, right? Some properties of C got inherited from A, some properties of C got inherited from B, right? All right, so this would be multiple inheritance. If we have to take an example, we can take an example. For example, we have a class physics, we have another class chemistry, but we have a mixture of both those classes in maths or something like that, right? So if we create an object of the third class, then we'll be able to access both of the other classes, right? Now this inheritance is very important. There is something known as diamond problem over here. There is something known as diamond problem over here. Let's take an example of multiple inheritance in order to understand this better. We have a class A, right? We have marks of physics in this class. We have physics in this class. We have a class B, right? We have chemistry in this class, right? Chemistry in this class. We have a class C, which has, now class C is a child of A and B. Class C is a child of A and B, and we have to inherit properties from them. So in order to inherit properties from both of them, we'll do public A and public B. It would be mode of inheritance class and mode of inheritance class, right? We have to put semicolons over here. Yeah, all right. So in this class we have maths, right? Now let's create an object. Let's create an object of class C. We have an object of class C, right? Right? Class name and object name. Object name over here is obj. Now what if for this object we have to access this member? What if for this object we have to access this member? Okay, we have to access obj.physics. We have to access obj.chemistry, and we have to access all right, over here we'll have this, and we have to access obj.maths, right? We have to access all the data members in order by creating object of this class. What will happen? For example, we have same values in A and B. What if we have same values in A and B? Which property will be inherited in C? Right? What if we have same values? We have chemistry over here, we have chemistry over here. Which of the chemistry will get inherited? For example, over here also we have chemistry, right? Which value will get inherited? We have an error. Okay, this error is because we don't have physics over here and we are trying to access physics, but okay, let's see. All right, so it gives an error that request for member chemistry is ambiguous. The compiler does not know which chemistry it needs to access, the A class chemistry or the B class chemistry. Now this problem is known as diamond problem. Right? Now how are we going to overcome this diamond problem? How are we going to overcome this diamond problem? Okay, diamond problem is something that we are trying to access same properties from multiple classes. So compiler gets confused on which property to access, which class property it needs to access. In order to overcome the diamond problem, we have to use scope resolution. How are we going to do this? Over here we have chemistry, we are printing chemistry, right? What are we going to do here is we're gonna mention the class name and we are going to do this. Now if we run it, we are having a garbage value, but we are having a value, right? So this is known as scope resolution, right? This is known as scope resolution. Let's move on to next type of inheritance, which is hierarchy hierarchical in, hierarchical inheritance. So in an hierarchical inheritance, basically we have some value. For example, we have a car and we have two child classes. We have one parent class car, one parent class, and two or more child classes. For example, car and child classes are Tesla, uh, Audi, Mercedes, right? So we have one parent class and two or more child classes. Now, in hybrid, what as the name suggests, as the name suggests, in hybrid we'll have mixture of all the classes, all the types of inheritances. We can have multiple inheritance, we can have hierarchical inheritance, we can have all the types of inheritances hybrid. Now let's move on to the next pillar. Let's move on to the third pillar. Third pillar is polymorphism. Polymorphism. Third pillar is polymorphism. Poly means many. Poly means many. And morphism means forms. So polymorphism means many form. Poly means many, morphism means forms, so it basically means many forms, right? We have two types of polymorphism. So basically we have two types of polymorphism. Polymorphism. One is compile time polymorphism, and the another one is runtime. So we have two types of polymorphism: compile time polymorphism and runtime polymorphism, right? Now, how as it means many forms, some people can think, how can we create functions of the same name? For example, we have to create a function print, right? For example, we have to create a function print, and we have to uh, create a function print, and we have to create a function print, right? Another function print. How are we going to do that? How are we going to create two functions of the same name? All right, let's see how polymorphism works. So first of all, let's see compile time polymorphism. Compile time, right? Okay, so it has two concepts. Compile time polymorphism has two concepts: function overloading, function overloading, function function overloading, operator overloading, right? So we have two functions in compile time polymorphism: function overloading, operator overloading. Let's understand these one by one. For example, for example, we have a class maths. Right? And we have some data members, public. We are summing two values. We are taking sum of two values and we are returning the sum, right? We have two parameters, a and b, and returning the sum. But we have another function inside this class of the same name, but the number of parameters are different. We have three parameters now, and it is also returning the sum, right? Now if we are creating a same function or another function of the same name, there should be some difference, right? if we are creating another function of the same name, there should be some difference. So the difference over here is number of parameters, right? There should be some signature value. So over here, the signature value is number of parameters. Number of parameters. So this is known as function overloading. Function overloading. Now, in function overloading, it is not necessary to have different number of parameters. What could have also been done is this value could be float. There is some signature difference. If we call this function over here in the main function, and if we pass the second value as float, it will call this function. If we pass the second value as int, it will call this function, right? There should be some signature difference. Now let's see what is operator overloading. Operators, we know that we have a lot of operators in mathematics: plus, minus, divide, multiply, and all of that. So operator overloading means there should be there is an operator which is existing in another form, right? For example, we have a class named parameter. Right? Param, for example, and we have a public data member functions value. We have some value over here. We have operator, and there is a plus. We are passing the object by reference. We are going to pass the object by reference. We have some values over here. Val1, this can access this value. Val1 can access this value over here, and we have value 2. This value can be the object's value, right? This value can be the value of object, correct? Now what we have to do is we have to print difference of both of these values. Let's go ahead and print difference of both of these values, right? And let's do endl. Just do endl. Let's create an object of this parameter. Let's have two objects of obj1, obj2, right? Let's have the value of obj1 as 7 or 8. Let's have value of obj2 as 5. Correct? Now what will happen if we will do obj1 plus obj2? What do you think will happen if we'll do obj1 plus obj2? Even though we have a plus operator over here, it will go into this function, because this plus is identifying as a character over here. This plus will go over here. This is not an operator anymore. This is just a definition of function. This will go inside it. It will have values and it will print the difference. So this function, if we call it, will basically print difference between the two values, right? This function will basically print the difference between these two values. All right, we don't have a semicolon. This function will print difference. Okay. All right. obj2, because we do not have an object, we just have, like, if we were passing by reference the value of obj, but we do not have an obj, right? All right, obj was not declared in this scope. Yeah, obj2.val. This should be obj2.val as well. And now we are having more errors. We'll look into it. Yeah, we'll have to look into it. All right, we can store this answer and we can maybe print it. OBJ1. Okay, we cannot do like this, I think. Yeah, void value not ignored as a dot. I think it's some compiler thing. We have to figure it out. Okay. All right. All right. So we have understood the compile time polymorphism. We have function overloading. We have operator overloading. Same function, like the functions with same name, but there should be a signature difference. The operator overloading means the operator looks like something else, but the function of that particular operator is something else. Its behavior is something else. Now let's look into runtime polymorphism. Let's look into runtime polymorphism. Alright, runtime polymorphism means polymorphism after the execution. Polymorphism after the execution. Right? Now this one has function overriding. Function overriding. This one has function overriding. For example, we have an animal. Right? And we have a function inside it, speak. We have an animal, we have function inside it, speak. And it just prints speaking. I'm not writing proper code over here. It's just a way of explanation. And we have another class, dog. And it also has speak. Right? Now dog is a child class, right? But we do not have to put speak function inside the dog, right? We do not have, dog doesn't speak, right? Dog doesn't speak. Human can also be an animal. We can have human child class and we can print speaking, but inside the child class we are printing speaking, but inside dog we should not print speak. We should have bark, right? We should have bark. So over here function overriding comes into picture. Let's take an example. Let's understand it by an example. For example, we have a class animal. We have some functions over here. We have just one function, speak, and it just prints speaking. Correct? We have function, it just prints speaking. Now we have a child class dog. With mode of inheritance can be public, and the parent class is animal. We have some public things over here, and over here we have to override, right? Now we do not want it to print speaking, we want it to print barking. So we'll go ahead, call the function speak, like create a function speak, and just print barking. Right? Now if we create an object of dog, and we call speak on this dog, all right, over here this operator should come, not an equal to sign, and we have not added a semicolon over here. All right, so barking is getting printed, not speaking. So this is function overriding. It's nothing but in the child class we just have to change the name of function, and we have to mention how that function is different from the animal function, right? But if we create an object over here by this was static allocation, right? This was by static. If we create it by dynamic allocation, we have to do something known as upcasting. For example, we create an animal A. It will store the address as I told you in the last video, and we create a new animal dog, right? Over here we just named the dog class, but over here we have to name the parent class and the new child class, right? And then we have to call speak on this. Then if we call speak on this A thing, which is a dog, then what will happen? Okay, this is getting printed first of all, then speaking is getting printed, but we want barking, right? Speaking is getting printed, but we want to print barking because it's a dog. What do we have to do over here? We have to use a virtual keyword. We have to use virtual keyword over here. If we add a virtual keyword over here in the main class, in our parent class, and then run it, then barking would get printed. This is known as upcasting, right? If we are doing static allocation, we are fine. But if we are doing dynamic allocation, which is a good property because it uses heaps, it saves a lot of memory, right? A lot of time. So if we are using dynamic memory allocation and we are creating an object like child of a parent class and we want it to do something else, then we have to use virtual keyword in a main class, right? If we have not used the virtual keyword, until we use virtual keyword, the parents function gets called. Until we use virtual keyword, the parents function gets called. It will not even know there's something else in the dog function, right? Now there's a catch over here. If it decides on runtime, then we have to mark virtual, right? If we want to decide it on runtime, then we have to mark virtual, and runtime on the runtime it will decide that we do not have to print speaking. It's marked as virtual. We have to print something else. We have to print barking, and it will print it. Now, as there is something known as upcasting, there is also something known as downcasting. Let's see. Alright, there is something known as downcasting. Now, if we create an object, for example, let's create an object P. We have to create it like this. New animal, right? And on this B, if we call speak, it will call speaking. We have a dog B. We have div reference over here. We have created a new animal. Dog is an animal, and we are creating having speak, but it is an animal, right? It is an animal, so it will call speaking function. Every time the method of pointer will be called. Inside the pointer we have address of animal class. Every time the method of pointer will be called, right? So we have four patterns basically. We have parent, new parent, which is a simple way to create an object. We have parent and a child, right? We have a parent and a child. Then we have a child, which is a new child, right? Okay, child A, which is a new child. And the fourth one is, we have a new child which with the dereference pointer. With the dereference pointer, it is a new parent, right? This one we have created over here, right? All right. So let's move on to the next pillar, which is abstraction, which is the last pillar, abstraction, right? Abstraction basically means implementation hiding. Abstraction is nothing but implementation hiding. We can also say that encapsulation is a subset of abstraction, and we can have abstraction through access modifiers. We'll understand abstraction more in detail in the next video. Thank you so much.